Continuing on, Chapter 9, examining the point data objects. We're working in the site table. This is part 2 video. We discussed loading the data and looking at the user site ID and the importance of consistency in the population of the data. What I want to cover now are some of the new features that we've added into NASIS 6.3. The state FIPS, the county name, and the MLRA symbol were typically handled in the overlap tables, and I'll discuss that in just a second. And we've now moved those here into the site table so that we can get some consistency in the population of this information. And then we follow this with the RACA, Rapid Carbon Assessment columns that were added for the RACA. We also have a DSP for dynamic soil properties. We also, most of this has to deal with specific needs for dynamic soil property sampling, and you can run your view information on any of these to obtain more information about that particular field. The next thing is the latitude degrees, minutes, seconds, direction, longitude degrees, minutes, section, and the datum name. If you populate latitude, degrees, minutes, and seconds, longitude, degrees, minutes, and seconds, do not forget to put in your direction, and do not forget to put in the datum that information was collected. It is required to have that datum name because those latitude and longitude degrees are tied to a specific datum. Scrolling on over, I'm going to show you the location description. The location description is used for meets and bounds, and those of you who do not know what meets and bounds is, it means you're probably working in section country. This allows a describer to identify using the meets and bounds coordinates of how to get to that particular point. As you can see, some of these were used to basically populate some sort of location information about where we were at when we described this. But for the most part, location description is for meets and bounds. And then you have the section, the township section and range information. And those of you that are using that particular section, township and range, you understand the system in which this is populated. Do not forget the meridian that you're using. And then we have the UTM. And you have the UTM northern and the UTM easting. And you can see that we have many methods of being able to populate those particular sites. I want you to realize, though, in NASIS 6, we basically went to a standard latitude and a standard longitude. These are decimal degrees. They are WGS 84, and that's typically what your default set is on your GPS. The requirement now is the standard latitude and the standard longitude. You don't have to populate the UTMs. You don't have to populate the latitude and longitude. You don't have to populate the location description. You can just go right in here from your GPS and populate your standard latitude and your standard longitude. And this will provide a consistent method in populating the database so that we can all use the site information. Then you've got the coordinate source, and it's a choice list field, and it allows you to identify how that particular location was populated. Your elevation, as with all features in the NASIS database, is in metric, so we're at 849 meters. You have your geomorphic components, still part of the site information. You've then got your hill slope profile, and all of this information. USLE slope is the slope for a USLE, not your upslope length is your entire landform length. Your USLE is specific to a point of concentration to the point of dispersal. Then you have your slope information. You have your local physiographic name. That's a free-form text note that allows you to populate what the physiographic area that you're in. Your drainage class, your KSAT above the horizon KSAT, pardon me, your upper KSAT range and your lower KSAT range. You have your obsolete permeability. And then once again, you've got your parent material group name. Remember, anytime you see the word group, you know that there are other tables, child tables that are to be populated in order to calculate that particular field or particular table. Your climate station information, and then following up with all of your climate, and then your water, your flooding frequencies and your ponding frequencies. And you also have, if you wish to, your GPS positional error, PDOP, and then your corrected elevation. So I hope that gives you a background on the site information. It's basically the geographical or spatial area that you're residing in before you take that particular pet on. So let's go in to look at the child tables. And the first one by default is your site observation. And then after that, by alphabetical order, are your area overlaps, your associated soils, your bedrocks, your ecological site, your geomorphic description, your overlaps for your map units, your vegetative parent material text, and then the quadrangle. We're going to start with site observation. And actually, I think what I'm going to do is I'm going to okay, I went ahead and found the particular site that I was wanting to show you for a demo, KS 07535. And now we are in the site observation table. What is the site observation table? First table that you populate is a site table. Second table that you populate is a site observation table. And the reason why is because it defines the date in which you've observed that particular site. And here is a prime instance. Once again, I'm going to do a best fit so we can look at this. What we've done here is I've got two site observation dates for that particular site. One was in 2001, one was in 1957. And I'll explain to you a little bit more on that here in a minute. But this is the date that was actually, the site was actually observed. Could be the date that you actually just populated the profile description, or it could be the date that you put in your monitoring equipment. So those are our three choices for that particular date. And then you'll notice that we've got the data collector, we've got the aerial photo, we've got the surface water. A lot of this information is pertinent to that particular date. And that's what the site observation date allows you to do. It allows you to set a site and then allows you to go back time and time again to that same site and collect and populate data. And so what you'll see here is information pertinent to dynamic changes on that site. And we've got quite a few different, we've added to this list in the table a great deal, even more so than I realized when I was looking at this. So you can see that there are a lot of information that you can go back to that particular site and you can collect information at that particular site on that particular date and be able to record the information. Notice that I've got child tables here, and I can come down here to the child table on that particular date, and we've now got information that is a one-to-many relationship. In other words, I could have many iris tubes, I could have many text entries for that particular site, I could have many soil temperature readings for that particular site. So the child table allows you to record a lot of information on that particular site on that particular date. Now then, I had explained to you that we've got two different site observation dates. Now, why did we do this? Because what I chose to do on this one is, this is the one I was referring to on the taxonomic unit description. I went back to that particular taxonomic unit description. I entered that particular date, the original TUD, and then I re-described the TUD, almost 50 years later, 45 years later. So that's the reason why I chose to use one site, multiple observation dates, and then I will come over here and do a find related on this selected row, and I will find that related pedon, and it's not in the not in here. So I can go back to here. I can do a find related, and I can find that particular pedon. So this ends part 2. We're going to go into another discussing pedons. So next video we'll start where I'm at right now.